Greetings again, everybody. Another video on equations and inequalities for the Year 12 AS aspect of the course. Today we're going to remind ourselves of inequalities, building up from the basics from GCSE and extending on to a new type of way of writing equations and inequalities called set notation. So all of it will be explained in this video. But before we get started proper, you need to get warmed up. So here for you now are 4 warm-up questions for you to attempt. Try each one in turn. Once you want to see the solutions, play the video again and just check yours against mine, make sure you're on the right lines. If not, go back and correct. So let's have a look together first of all at question number 1. So for question number 1, it says without using a calculator, big thing there, don't cheat, find the coordinates at the minimum value of this function f of x equals 2x squared minus 6x plus 7. To find the minimum or maximum, we can complete the square. Okay, so completing the square tells us what the minimum or maximum will be. And so what we can do is factorise out this 2 from the x squared minus 6x. So what we get next is 2, and in big brackets, x squared minus 3x plus 7. Then what put in these big squared brackets can be completed the square upon? So what we do, we put the x squared, we just put an x inside the brackets. We half the coefficient of the x term, so half of minus 3 becomes minus 3 over 2. We then square everything. We subtract off the minus 3 over 2 squared. So minus 3 over 2 all squared is 9 over 4. So we subtract away 9 over 4. And of course you have this plus 7 at the end to deal with. We can now expand this out. So we have 2 lots of x minus 3 over 2 all squared. Then 2 multiplied by minus 9 over 4 becomes minus 9 over 2. 2 times 9 is 18. 18 over 4 can simplify to 9 over 2. And then of course this plus 7. But what I'm going to do here, I'm going to rewrite this plus 7 in a slightly different way. I'm going to write it in terms of halves. So I'm going to write this as plus 14 over 2. Then what I can do is I can combine these two fractions together in one constant term at the end. So I'm next going to have 2 lots of x minus 3 over 2 all squared. And these two fractions, 14 over 2 minus 9 over 2, will leave me with plus 5 over 2. We now need to recall that when an equation is written in its completed square form, this value here and the constant value at the end tell us effectively what the turning point is. And so in this particular case, we've got 3 over 2 and 5 over 2. So what it tells us is the turning point, in this case for minimum value, is going to be when x is 3 over 2 and y is 5 over 2. And that's all we need to do. It's just a case of recalling our earlier work on quadratics. So that's question 1 sorted out. Question 2, we've got this quadratic equation here, k plus 1 x squared plus 12x plus k minus 4 equals 0. And first of all what we need to do is show that k squared minus 3k minus 40 is less than or equal to 0. But the key thing here is that this equation has real roots. And so what I'm going to do first of all is just section this off so don't get parts A and B mushed together. Okay, so show that k squared minus 3k minus 40 is less than or equal to 0. Now I did say this is the key thing. If a quadratic equation has real roots, what that means is that the discriminant is non-negative. So because we have real roots, what this implies that b squared minus 4ac is non-negative. In other words, it's equal or greater than 0. So in our case, what does b mean? What's a? What's c? Well, you need to know that a is the coefficient of x squared. So in this particular case, a is k plus 1. b is a coefficient of the x term, so b is just simply 12, and the c parameter is the constant term at the end, which is k minus 4. And so if we substitute in for b squared minus 4ac, b squared is 12 squared, then minus 4 lots of a, which is k plus 1, then multiplied by c, which is k minus 4. That has to be greater or equal to 0. This can be simplified down. 12 squared is 144, then minus 4 lots of this bracket. So if we use FOIL or any equivalent method, k multiplied by k gives us k squared. K multiplied by minus 4 is minus 4k, plus 1k from here though. So overall we have minus 3k. Then 1 multiplied by minus 4 is minus 4. And that needs to be greater than or equal to 0. If we now expand all this out, we get 144 minus 4k squared. Minus 4 multiplied by minus 3k is positive 12k. Minus 4 multiplied by minus 4 gives us positive 16. And that's at least 0. We can now simplify further. So we've got minus 4k squared plus 12k, and 144 plus 16 is 160. Now, because each of these coefficients of the variables and this constant at the end are all multiples of 4, and this is just 0, we can divide this whole thing by 4. So if we divide the left-hand side by 4, and the right-hand side by 4, and then we can go one stage further as well, we can actually divide by minus 4 to make this a positive k squared. So if I just pop in a minus there, and a minus here, we're going to get k squared. 12 divided by minus 4 gives us minus 3k. And 160 divided by 4 is 40. So divided by minus 4, that gives us minus 40. And what we need to remember, when we've got an inequality and we multiply or divide by a negative value, we switch the order of the inequality symbol. So we reflect this in a vertical axis, and it becomes this way round. And that, if you see here, from part A, that's what we wanted to prove. So that's part A finished off. So I'm just going to put this in a little blue rectangle to show that that's what we wanted to prove. For part B, we now need to prove, using this, what the possible values of k are. So I'm just going to copy down this again. So we have k squared minus 3k minus 40 less than or equal to 0. This quadratic on the left factorizes easily. So two numbers that multiply to minus 40 and add up to minus 3, well, those numbers are positive 5 and negative 8. What I want us to do now is just to imagine a graph of k against this quadratic. So imagine now we were to graph not x and y, but k against this function of k. So what would that look like? Well, let's just have a think what it would look like. So if I just plot k against k squared minus 3k minus 40, we can see from the factorized form, this is going to have roots at minus 5 and positive 8. So it's going to have a root here and over here. So it's going to look something a bit like this. Badly sketched. I know I can't really sketch very well, but forgive me. So that's minus 5, and this is positive 8. And this needs to be less than 0 or maybe equal to 0. And so the values for when this is less than 0 is when it's below this k-axis here. And so it's going to be less than 0 for these values in between -5 and 8. So based on this sketch and the factorised form, we can say that k needs to be at least -5, but can't be any more than 8. And that's all we need to do for question 2. For question 3, we're told that x is greater than -3. Show this inequality on the number line below. I don't know if you remember this, hopefully you do, but if we've got a variable greater than a value here, we put a hollow circle above that number, like so. Then we show an arrow in terms of which direction x must be in. So if x is greater, it must lie on this bigger end of x. So we then put an arrow facing away from this hollow circle. Don't need to extend further, don't need to go like this, but just clearly pointing to the bigger end will do you. So that'll be fine. Part B, dead easy. Whoops, didn't mean to do a line again. Apologies for that silly little slip. You'll see lots of these silly slips if you watch enough of my videos. Anyway, add 34 to both sides. 8 plus 34, we get 42. Divide through by 7, we get that y must be 42 divided by 7. In other words, y has to be less than or equal to 6. And finally, for question 4, we've got 3 different parts here, A, B and C. So on the number line below, show the inequality -2, y, 3. So all these here don't include equal to y. So -2 and 3, we put hollow circles above these. So that's at -2 and that's at 3. Then put a horizontal line connecting these two dots, as so. For part B, we have an inequality shown in terms of x, shown on a number line. Write down the inequality. Well, we can see already that x is literally in between these two circles. So at one end, it's between -3, and at the other end, it's between the number 4. However, this circle here is filled in. If it's filled in, what we need to include is also the possibility that it's equal to this value. So we need to put a line underneath here. If you ever forget if it's a line underneath or not, just think about in terms of printing, what takes more ink, a hollow circle or a filled in circle? Obviously a filled in circle takes more ink. So this takes more ink, as does a symbol with a line underneath it. A bit of a stupid way it might seem to remember it, but it's always worked for me. And so the inequality here for question 4 is x is bigger than -3 and up to and including 4. And so that's for warm-up done. Next, some GCSE questions ultimately, but we need to be sure before we continue that you're absolutely solid and confident with solving relatively simple inequalities. I've got 12 of them here for you to try. I want you to try these on your own and hopefully get them all right. But you can use this video to just double check to see if you got them right, and then double check that your solutions match my own. So I'm going to just walk you through every single one of these inequalities, starting with this first one. So 2 brackets x minus 3 greater than or equal to 0. First off, expand out the brackets. 2x minus 6 greater than or equal to 0. Add 6 to both sides. We get this. Divide through by 2. X is greater than or equal to 3. That's the first one. Second one, expand the brackets. So 8 multiplied by 1 is 8. 8 multiplied by minus x gives us minus 8x. And that's greater than x minus 1. Add 8x to both sides. We get that 8 is greater than 9x minus 1. Add 1 to both sides. 9 is greater than 9x. Divide through by 9. We see that x is less than 1. Question 2. First off, expand the brackets. We get 3x plus 21 is less than or equal to 8 minus x. Add x to both sides. we get 4x plus 21 is less than or equal to 8. Subtract 21 from both sides, I meant to say. So 4x is less than or equal to 8 minus 21, which is minus 13. Finally, divide through by 4. We see that x is less than or equal to minus 13 over 4. You may have said less than or equal to minus 3 1/4. That's fine if you wanted to. Next one, two lots of brackets to expand, but fairly simple. 2 times x is 2x, 2 multiplied by minus 3 is minus 6, and minus x, then think of this as being a minus 1 in front, if ever you get confused. So minus 1 multiplied by positive 12 gives us minus 12. Simplify. 2x minus x is 1x, minus 6 minus 12 is minus 18. Finally, add 18 to both sides. We see that x has to be less than 18. This one, again, some brackets to expand. So first of all, expand them. 1 plus 11 times 2, that's 22. 11 multiplied by minus x gives us minus 11x. That has to be less than 10 times x is 10x. 10 times minus 4 is minus 40. Next we can add 11x to both sides and simplify this bit. So 1 plus 22, that is obviously 23. On the other side, add 11x to both sides. We get 21x minus 40 on the right. Add 40 to both sides. 23 add 40 gives us 63. So 63 has to be less than 21x. If we divide through now by 21, 63 divided by 21 is 3, so x must be greater than 3. Next up, once again, expand the brackets. So 2 lots of x is 2x. 2 multiplied by minus 5 is minus 10. That must be greater than or equal to what is 3 times 4, which is 12, and 3 times minus x, which is minus 3x. If we add 3x to both sides, we get that 5x minus 10 has to be greater than or equal to 12. Add 10 to both sides, we get that 5x is greater than or equal to 22. Finally, divide through by 5, we see that x is greater than or equal to 22 over 5. You can call it x is greater than or equal to 4 2/5 if you really want to. That's absolutely fine if you wanted to say that. Next, some brackets, so expand these again. So 12x just stays as 12x. Minus 3 times x is minus 3x. Minus 3 multiplied by minus 3 is plus 9. And that's less than 45. Simplify. 12x minus 3x is 9x plus 9 has to be less than 45. Subtract 9 from both sides. We see that 9x has to be less than 36. And then divide through by 4. We understand that x has to be less than 4. Next one, we have this. So again, expand the brackets. So we have x minus 2 times 5, which is 10. Minus 2 times positive 2 gives us minus 4x. And that's less than 11. Simplify. X minus 4x is minus 3x. We can then add this 10 to both sides. So we have minus 3x has to be less than 21. Now what we can do is divide through by minus 3. So x something 7. But remember, if we divide by a minus value, the direction of the inequality switches. So rather than the open mouth facing to the right, the open mouth is now going to face to the left. So in other words, x is going to be greater than something to do with 7, but remember we divided by minus 3. 21 divided by 3 is 7, 21 divided by minus 3 is minus 7. So be very careful with the negatives. Okay, so that's the final answer for that one. This one, again brackets, so expand them out. X multiplied by x is x squared. X multiplied by minus 4 is minus 4x. So we have that's greater than or equal to x squared plus 2. We've got x squared on both sides, so we can subtract off an x squared from both sides. So effectively it cancels. So we're then left with minus 4x is equal or greater than 2. If we then divide through by minus 4, 2 divided by 4 is a half, but 2 divided by minus 4 is going to give us minus a half. And more than that, the direction of this inequality symbol is going to switch. So rather than facing this way, it's going to face the other way, like so. Again, some brackets to expand. So if I expand these out, x times 5 is 5x. X times minus x is minus x squared. That's greater than or equal to 3 plus x minus x squared. Again, we have a minus x squared on both sides, so again this is going to cancel off. All we're going to be left with is 5x on one side and 3 plus x on the other. If we now subtract an x from both sides, we get that 4x must be greater or equal to 3. Then dividing through by 4, we see that x must be greater than or equal to 3/4. Almost at the end now. So again, some brackets to expand. So 3x plus 2x times x is 2x squared. 2x multiplied by minus 3 gives us minus 6x. Expand out on this side, 2 times 5 is 10, and 2 times x squared is 2x squared. Once again, you'll see that the x squared terms cancel. So now simplify on this side. 3x minus 6x gives us minus 3x. That's less than or equal to 10. We can now divide through by minus 3, so we get that x is something to do with 10 over 3. But because we're dividing by a minus, that becomes minus 10 over 3, and this inequality sign switches. So we have x is greater than or equal to minus 10 over 3. Finally, the last one, expand out the brackets again. So x times 2x is 2x squared. X times minus 5 is minus 5x. And then we have 4x times x is 4x squared. 4x times 3 is 12x. All of that over 2. Then minus 9. If we multiply through by 2, get 4x squared minus 10x is 4x squared plus 12x minus 18. Again, the x squared terms cancel off, so we have minus 10x is less than or equal to 12x minus 18. So add 18 to both sides and divide through by 22. We get that x is 9 greater than or equal to 9 over 11. Apologies if I whiz through that warm-up and revision at breakneck speed. I just want to emphasise that you should be fairly comfortable with those already, so I don't want to dwell on them. One thing which you probably won't have seen before, however, is set notation. So what I want to do here is introduce some of the items and symbols you may see in the A level, which may seem new and rather intimidating, but rather than just giving you the formal definitions, I want you to talk you through them in a more sort of informal way, so that you know exactly what they mean, so that when you see them, you're not going to be freaked out, put off, or confused. So, the first thing I'm going to just say here is essentially that it's new for this A level, really. When I did my A level, this wasn't really a thing. Okay, so I'm going to give you some examples below of what you may encounter. The first one is curly brackets, like this. Okay, so if you've got curly brackets, all these are used for is just to contain the entire solution set description. So in layman's terms, put simply, inside your curly brackets you put your entire answer for the inequality or equation. Okay, so the curly brackets just contain everything to do with the answer. A colon, not to be confused with a semicolon. Okay, so the colon, which again goes inside of these curly brackets I've mentioned above, it introduces the solution range for the variable that's written before the colon. So for example, usually it's going to be an x. So you'll have an x colon, then it explains what x has to be. So you can think of a colon as being the words such that. So x, such that x is greater than 5. Another way you can think of that is the required range of x is x greater than 5. Here's another example here. So it might not always be x, it might be p. So this here means p such that p is greater than or equal to -3, but less than 7. Or you can think of the colon as saying the required range of p is whatever follows it. The next one is like a weird N looking symbol, and this is called the intersection, the set intersection. This symbol means the intersection of multiple sets. In other words, when the required solution must include multiple sets together. So not just one option, but another option as well. So in the context of inequalities, it's essentially the word and. Okay, so if you see the N symbol, think and. So to give you an example, if you had x such that x is greater than 5, and x such that x is no greater than 11, what this means is that if x is greater than 5 but no greater than 11, this can be merged into 1. Okay? It means that the solution range for x is when it satisfies both these conditions. So if you have a set intersection, this N symbol, it can always be merged into one set of curly brackets. So putting these two together, it's the same as saying x must be such that x is greater than 5, but less than or equal to 11. So this intersection means overlap. So this symbol can always be removed, and the two or more sets of curly brackets can be merged into one solution set, where the solution set of a merged group satisfies what's in the overlap. Opposite to the intersection, or not opposite, but different to the intersection, but often confused with it, is the set union, which has this U symbol. So this symbol means the union of multiple sets, when the required solution must include some combination of these sets, but not necessarily simultaneously. So it's not and, it's just more so the word or. So one or the other. And it could be both as well, but because it's or, there doesn't have to be an overlap. And so the solution sets could be not exclusive. They could be mutually exclusive to each other. For example here, x less than 5 and x greater than 11. There's no overlap there. So if there's no overlap and it could be one or the other, we'll leave this U symbol here for union, saying that although there's no overlap, we don't mind if it's this one or this one. Okay, so that's all it means. It's a more complicated way of writing it in the standard form, in a sense, but it's a more formal use of notation, which you may encounter. So to give this a bit of life, I'm going to show you how these work with some worked examples. So worked example 1. So find the solution set for which 3x minus 5 is less than x minus 8, and then also 5x is greater than x minus 8. Give your answer in both standard form and in set notation. So what I'm going to do here, I'm just going to section this off into 2 separate bits. Okay, so let's get rid of that as well. So what I'm going to do first of all is think of this inequality first. So we've got 3x minus 5 less than x minus 8. So let's rearrange this and solve this part of it. Okay, so all I'm doing here is focusing on this aspect. So if we subtract an x from both sides, we have 2x minus 5 less than minus 8. We can then add 5 to both sides. So minus 8 plus 5, that gives us minus 3. Finally, when we divide through by 2, we see that x must be less than minus 3 over 2. So from this equation, sorry, not equation, inequality, bad of me to say that, we have this solution. Meanwhile, we also need and we need this to be true. So let's solve this one. So 5x must be greater than x minus 8. So again, this is fairly easy to rearrange. So if we subtract x on both sides, we see that 4x must be greater than minus 8. Then dividing through by 4, x must be greater than minus 2. Okay, so in the standard form, so writing this answer in standard form, we'd see that x has to be less than minus 3 over 2, and x must be greater than minus 2. But in set notation, this is one and the same thing. So a double-headed arrow saying one implies the other and vice versa. Because we want both of these, we put the curly brackets to denote our answer. We want x such that, well, think about it here. So we've got 2 different things. So one thing we're saying is that x has to be greater than minus 2. Okay, so down here we can start with saying minus 2. X has to be greater than that. But x has to stop not long after minus 2. In fact, in terms of how big x can go, it can only go as big as minus 3 over 2. And so we put this range in here. That's our completed solution range, so then we close the brackets. So that's the answer written in set notation. Let's have a look at another worked example. So find the set of values for which x minus 5 is greater than 1 minus x, or, this time, 15 minus 3x is greater than 5 plus 2x. So, again, what I'm going to do is section these off and solve separately. So first off, we have this. So x minus 5, oops, I'll do this in block actually. So x minus 5 greater than 1 minus x. Add x to both sides. 2x minus 5 greater than 1. Add 5 to both sides. 2x greater than 6. Divide through by 2. X has to be greater than 3. So from solving the first inequality, we have this. Now solving the second one, 15 minus 3x greater than 5 plus 2x. We can add 3x to both sides. Then we have 15 is greater than 5 plus 5x. Subtract 5 from both sides, we then have 10 is greater than 5x. And finally, divide through by 2. What we see there is that x must be less than 2. Or 2 greater than x, whichever way around you want to do it really. So, now in standard form, we've got two different answers. So x can either be greater than 3, or it can be less than 2. There's no overlap. So we'd say here that therefore x can be greater than 3, or we can have x less than 2. Now in set notation, here, these two ranges do not overlap at all, so we can't put them in one set of curly brackets, but we can join them together with the symbol that means or, which is this union symbol. So, we can have x such that x is greater than 3, that's one range, or we could also have x such that x is less than 2. So all we're doing here really is just illustrating that this or is the same as this u symbol here. And so that's the two different ways we could write it. So in standard form or set notation, which I've wrote at the end. So once you get your head around it and practice it, it's not half as bad as what it may seem. So that's all from me. Now from you, I want you to do some practice. So if you turn to page 47 and see exercise 3D, try question 3, and then have a go at that challenge question. If you can do that challenge question and understand the set notation needed for that, you've truly nailed this idea of set notation. If you get stuck, let me know, and if you're not sure of, let me know, either in class, in the video section of the comments, or in an email if you can't reach me. Thanks again for listening, and you'll hear from me again soon. Bye for now.